Okay.
Okay. Thank you very much. I'm going to say a few words, Alexander, in Hebrew, and then we can move to English. אז שלום לכולם, צהריים טובים. תודה שהצטרפתם להרצאה השנייה היום. כפי שאמרתי בהרצאה הקודמת, היום שלנו עוסק בעצם בדאטה מנג'מנט, ניהול נתוני מחקר. I'm very happy to introduce our presenter, Alexander Bardel from Graz University of Technology in Austria. Alexander is a data steward and an RDM officer in the RDM team at Graz University of Technology. His responsibility include data stewardship, consulting, training, policy development, and etc., and project management support for shared RDM services and infrastructures. His main focus is the development of training and introductory material on RDM topics and tools, especially an electronic lab notebook called eLab FTW. A program for researchers interested in RDM named Data Champions is also part of his task. He has I'm sorry, a master degree in technical physics from Graz University of Technology. Please, Alexander, the stage is yours.
Yes. So yeah, thank you very much for this nice introduction, and thank you for the invitation. So I will start by sharing my screen. So, okay, I think you can now see my screen. Is this correct? Yeah, perfect.
Yes.
Okay, so yeah, so my Tuesday's talk will focus on the topic of modern research data management and the practices and the steps which are essential if you want to move towards open data. So what do I want to cover today? Which content I want to cover today? I want to give first a short introduction about the terms of open data and research data management, or in short, RDM. Then I want to briefly discuss why open data matters. So what's the point in all of it? Then I want to also show you the topic of research data management and open science policies. So why are they important an important step here? Then the main part of this presentation will be the practical aspects of RDM, where we'll show you some important tools, but also techniques and also some examples from the real world. Then I will also cover briefly the role of a data steward towards the end. So what is this role, and why is it also important to have this in your institution or your university? And at the end, I will sum all this up in a really short conclusion. And of course, we don't have time for your questions, and I will try to answer them. So research data management. So research data management accompanies the research process from the initial planning stages up to the active phase of research, where you have intermediate storage, and then towards the end, an archiving phase and this publication phase. And research data management accompanies really the whole research process itself. So it's dealing with the data that you produce or that you use during your research processes, and it therefore tackles with the things like data generation, data cleaning, modeling, analysis, visualizations, the exchange, but also the deletion of data. Sometimes forgotten, but also a very important topic here. So this is covered under the whole topic of research data management. On the other side, open research data. Tried also to introduce the term research here, but it's not necessary here. I want to clarify what exactly is open data. So what do we talk about here? So open data is data that is freely accessible to others and can be further used freely on the basis on a suitable license. And this topic of suitable license is pretty important here. We'll cover this towards the end, almost, because without these licenses, open data is not really possible. And when we talk about open data, it's also have an idea about what is actually data. And here is just some examples here. When we talk about open data, we talk about the raw data you generate, but also the process data. This can be analog or digital. We talk about simulation data, data from observations, from interviews, from models, software, also personal data, can also be information about physical objects, but also workflows. And very important, when we talk about this topic, it has certain features, open data. So open data should be of high quality. This data should also be well described, so it needs a specific amount of metadata, and this amount can vary depending on the situations, that it comes in a well-structured form, and it is also correctly stored. So this is somehow connected to the FAIR principles, which I know you already heard earlier. So I don't want to tackle the FAIR principles here again. So I just want to say briefly one slide. We'll show you one slide about it. The idea, I talk about open data and open science in a general term, is that the work you do and the things that you publish, it doesn't matter it's the manuscript or the data itself, that these things should be towards as fair as possible. So findable, accessible, interoperable, reusable, but also as open as possible. So there's always some field of tension between these things. So applying the FAIR principles does not necessarily mean that you share your data openly. So this is something you should always have in the background, that the FAIR principles can always be applied, but it's not equal to open data sharing. But, and I want to mention this because it's something that's very important for me, it's a really solid foundation. So FAIR principles are really solid foundation for the sharing of open data, open workflows, whatever. And these FAIR principles are best practice for data exchange. So when it comes down maybe to sensitive data or cooperations between the industry and the universities. And even in the case that the data is not shared at all, because you have some restrictions, the metadata that is a core is so as I mentioned before, well described, is somehow findable, and this also describes your data well, so that it can be still used in the future for you and for others. So now I want to move on and talk a little bit about why open data matters. So why is this important? And we have some trends in scientific research. And when we look back to the past, or sometimes it's also in the present, that we had established culture where researchers worked as focus experts, and they also worked with the self-generated data. Could be different reasons. Sometimes it's just a trust issue. Sometimes it's just something that you want to work. That the whole process itself of generating data is something that is strongly connected with your work. It's important in the point. But what is important, that we are now moving in a different direction, and that is what we are moving towards data discoverability. So we have to find a way that this data is findable and usable, and to dealing with this data in structured collaboration. So you are not working alone anymore. You're working together in groups. Of course, this is something that is still present, but with groups from together in a way that you work collaboratively within different universities. And to achieve that, we also need to build a sustainable and open research infrastructure. So in most of the cases, this is not present. So we need techniques and also software, but also really infrastructure that makes it possible to do that. And this together also comes with a rise in data-driven research itself. So we have this trend, but we have also a need on the other side. And these collaborations and of course this interdisciplinary research, so people from different disciplines working together, are the only way to address societal challenges today. So this is a short overview. I took the United Nations 17 Sustainable Development Goals to see what this is an example for societal challenges. And as you can see here, you find a couple of those challenges. Let's see, clean water and sanitation, or climate action, life below water, life on land. It doesn't really matter at this point. All of these challenges can just be achieved by working together, and you need some kind of instrument and some kind of policy sometimes to achieve those goals. So this is the reason why we are doing all of that. But there are also other benefits when it comes down to open research. So this open data brings benefits to various stakeholders in the community. So sometimes these benefits also overlap. So we have these benefits for the individual researcher. I think this is a really important part, because I think the most of us who were doing things, they want a personal benefit out of it, some added value. And this is, in this case, there is something. So you get better recognition, a greater recognition, more citations, of course, also a greater discoverability of your work, but also of the work of others. Also, there are a lot of benefits for the research communities itself. So like that we have more resources available because we have a more efficient use here as well. And this is, I think a really important point, also from a society view, that the society as a whole, also the public, can have an increased trust in research when this research is available. So we're talking about also research that is done not inside of universities, so sometimes from public partners. And also, of course, economic benefits and others as well. So after doing this, I want to talk a little bit about this RDM and open science policies. And I'm aware of this fact that policies are a topic that is often ignored or even negatively associated. So because policies have sometimes to do with politics, to keep it simple. And this is also, when it comes to policies, especially by practitioners that ignore this or have a negative association with it. However, they are pretty important because these policies create a framework that enables certain stakeholders, and you saw a couple of them on the slide before, to become active in the research community, and or also give them a mandate to do certain actions. So to start with certain actions. And policies often are a political tool as well, but they can have very positive and practical impacts if they are used correctly. So what do we need for this policy development? And what is the content about? So research data and open policies describe the guidelines for handling the research data. So this is more or less associated with the research data policies. But they also describe the principles and the funding under which open science should take place. So depending on the background, if it's more research data policies, open science policies, they're taking different parts, but they're always describing something. In one case, there are the guidelines, on the other side, how under which principle this work should be done. And what is very important, if you want to develop these policies, you should always include the relevant stakeholders. Do not leave people out who are affected by these policies. It's important that they're on the table. What you write or what is in this policy must also be practical and feasible. there is no sense in it to describing something that is not reachable. So it's important that it is something that's practical and feasible. And also to use a clear language and concept that can be understood by the community and by the stakeholders that are involved. And in an ideal case, you also describe all the relevant roles in your policy and what are their responsibilities. Something that is always pretty handy is if you have an appendix in your policy, please describe the key terms you use there, because there are a couple of terms especially for people who are new to the topic, they don't know what you're talking about. So it's important to have this in the appendix. There are different types of RDM and open science policies here, and I just want to mention a few of them. So we have national policies. In our case, in Austria, we have an open science policy, Austria. I will share the slides with you later. I think that's okay. You have then the links and you can check them if you want. We have policies from our funder side. So from the FWF, it's called the Austrian Science Fund. They have also an open access policy regarding the research data in the work they funded. We have also publishers policy. So Biomed Central, I think it's also part of Nature Science, I think. And they have a policy regarding the open data that is published in Biomed Central. And we also have institutional policies. I think that is maybe the more interesting part for you. In this case, at Graz University of Technology, we have a framework policy for research data management. And in this research data management policy, it's a university-wide explanation of general principles and overarching responsibilities where we that cover the topics of research data management in the daily work of our researchers at TU Graz. But they're not the only group involved in here. So in our policy, all of the relevant stakeholders are described. So we have the faculties in this policy. We have the rectorate. We have a group that's called the Research and Technology House. We have our legal department involved. We have the library and also, and that's very important, our central IT services. So they're all mentioned in this policy. What role do they have and how they should act in this one. And this was developed by a working group, which contained of all of these representatives, and it was approved by our rectorate. And there is a sub-chapter in this framework. It's called the faculty-specific implementation. So this is a sub-chapter which deals with how these guidelines should be included in each and every faculty, because these faculties are different. So you cannot have one policy that fits to them all. So you have to implement something on your own. And what are these advantages? What is the advantages not to have an high-level policy, but also something that is dealing on a lower level? You have the chance in this faculty-specific implementation to defines the distribution of the roles of the faculty. So you have different roles in the faculty. This depends on the university, on your culture, whatever. And you can define what roles do you have and what responsibility those roles have. So you can clarify this at this point. Also, which rights these people have. Maybe access to different kinds of resources that they need for their research work. Maybe some kind also financial resource if they want to publish open data or open manuscript. It is, as I mentioned before, an enabling factor for the implementation. Without the policy, you do not have a mandate, you do not have a plan, you do not have some kind of structure, what should be done in your faculty, in your working group, in your institute. In our case, it was also part of a digitalization strategy of TU Graz. And this is connected some kind to a project called European Open Science Cloud. Also, international developments are moving in this direction. So to have this kind of policies in place is something that is also an international trend here. And this is why we have this advantage of faculty-specific implementations. And if you want to check them, there are open access. So you can also, with the link you will get later in the slide, from the slides, you can also check it via TU Graz sites, RDM on policies. You can see our framework policy and also 2 faculty-specific implementations as well. So you can check them out if you like. So we're now moving on to the practical aspects of research data management. And I would like to start with the research data lifecycle here. So what you can see on the left side here is the research data lifecycle, and they're maybe the most important sectors. So we have, of course, as you already know, we have the preparation phase, we have the discovery phase, we have the analysis phase, we have the writing phase of research, then we have at some point the publication, and also the outreach and assessment phase. So in all of these phases, research data management and of course open science, and with today's topic, open data, play an essential role here. And I thought this really nice visualization of what open data or data can be. And there is this really a broad spectrum of what research data can be, but it depends always on the application. Sometimes open data is just related on some tabular data, like a CSV file or something like that, or a text file, but there's really more of it. As you can see here, it can be documentation, it can be audio files, it can be presentations, it can be video code visualization. So this everything you can imagine. Here it is mentioned that with the exception of your research manuscript, most cases that's true, but also the research manuscripts can be under some circumstances research data itself. And there are concepts and formats that are easier and more difficult to handle, some which are open and commercial formats, and some of which are available for a long time and more of a fashion phenomenon. At TU Graz, we have a more simplified version of this research data lifecycle, and we clustered it into 3 parts. So we clustered it into a research planning phase, an active state of research, and a research complete phase. And under the research planning phase, we defined 3 points. So the defining the requirements that come from funding agencies to researchers, then clarifying the legal framework and ethical issues under which the research has to take place, and if it's possible to reuse already existing data, open or not. In these situations, we are working with data management plans, and we have also a tool that is called DMB tool as well here. You can see, we will see later. Then in the active state of research, of course, we have this part of collecting information, processing it, analyzing it, also tracking where it is used, and also sharing it during the research work with different working groups and also inter-university. Here we have also some very handy tools in place as well. We use GitLab. We have our own GitLab instance for sharing code and code development. We have an electronic laboratory notebook, ELABW, and we have also a data analysis and management platform called Cyrus Austria. And in the last part, in this research complete phase, it's all about the preserving of the information, giving others the access, a control access, and also enable others to reuse your information. We have our own institutional repository called the TU Graz repository, and it's based on a software called Invenio RDM, which is also used in a platform called Zenodo, which is a solution from CERN. We are part of this project. And over all of this research lifecycle, data stewardship is a pretty important topic. It's related to the term of a data steward, but we will see later what's the difference, and I will explain it a little bit better. At TU Graz, we also have our own philosophy and mission on how we want to tackle this topic. And what we are doing is that we want to create all of these services under that they are researcher-led. So we include them in our developments. And these things are not just technical problems or technical challenges. You have at the same time, you need also social solutions in parallel to get the most out of it. And what we're also doing as a unit that is working as the research data management unit, which was briefly mentioned in the introduction, we're working between as a closing gap between the researchers and the support staff. And we're doing this through tools on the one hand for research data management and open data. So we have data management plans, we have this other topics we have, and we do it also with soft infrastructure solutions, so to say. So we're working with policies and guidelines, and also, of course, with data stewards and our team. And on the other side, we have also services. We have an information hub, we have community events like, I mentioned before, this Data Champions program, and we also organize training and individual support. I mean, all of this stuff is really important to get this cultural change in the research community towards community that is able to produce and also share this data in an open way. We also created a dashboard for that. You can see it here, but just briefly, I want to show you it. This is how it looked like, our research data management platform, where researchers have the possibility to check out different information sources here, our tools, also optimization, whatever they need, if they need information on something like that. They have the way to check this out and also to get contact from our responsible contact points at our university. So the first thing I want to show you was the topic of data management plan. I know there's on session on that, so I will keep it short. But DMPs are really, really important, and they're a good starting point for doing research data management. Also with a short example here, where you can see that the group is so one group member left the team a time ago, and now they want to have some of this unpublished data that he had. This is already the first important point with a good data management plan that is available for the others in the team. This wouldn't be such a big question. But if you move on in this comic, you can see that there are also other programs like, okay, which software was used? Is there an alternative? Maybe, the documentation, so the metadata was not properly. Maybe is there a second documentation which was not in a handwritten notebook or something like that? So all of these things are tackled in a DMP and are briefly explained in this short comic. But DMPs traditionally have several parts for here really important. So that describe the data collection documentation. So what kind of data you generate through your work, how it will be generated. If you have to tackle some ethic or legal issues here, what are you doing with your data through your work? So where do you store it? Is it safe? Are there backups in place? So there's really important questions that are sometimes answered with a no. And also how do you want to share your data? So do you want to share it openly? Is it not possible to do it? Are there some restrictions? All of these things should be mentioned in the system, and also how in this data management plan, also how to access it. There are different tools available for you. This maybe are more the most famous ones like Argos, DMP tool, DMP Online, or DS Wizard. But at Graz, we use another solution called DAMUP, which we're also in co-development with the TU Vienna. It's called the TU Graz 22. This is just a screenshot how this solution looks like for the user. It guides you through different steps. And since it's a living document, you can also change these things, can export it, send it to the funders, other parts of the university, to your colleagues, whatever they need, give them access. So it's a pretty handy tool for data management. There are some added values. You can read it if you want, but what is really important, or which I want to mention here, is data management are time-saving for research. So doing this saves you time. Of course, you have some initial work you have to do with that, but overall, your whole research process, you will save time because you will see opportunities and problems at an early stage, and you can use this information. Also, things like data loss can, through planning a good backup scenario, can be missed through that. And also about this part, archiving and use of data. If you start thinking about this at the end of the project, this can be a little bit critical because sometimes it's also connected with money. So dealing with this topic at an early stage can save you a lot of time and money as well if you maybe ask for additional funding at the beginning. So think about that through writing this DMP can help you really with your research work. But you can do things also without tools. So there is basic data management, and you can do things also without additional tools. So what you always should avoid is, how did I name my file? Where did I put it? And what is what? So I think this is something that all of you and myself are asking ourselves. But this is something we should avoid if possible. And there are different possibilities to do that. So there are different rules. What you should do, you should always work in a clear hierarchical folder structure. So it sometimes seems simple, but this is something that is really important. Have a hierarchical folder structure with similar subfolders comes pretty handy here. This works together with the 7-folder system rule, where you have 7 folders in 3 different sublevels. And this is fine, but if you have sensitive data, it can be also a good idea to have a separate structure for that. So do not mix things, because you will forget where your sensitive structures are, sensitive data are. And if possible, and I know this is not always possible, but really the files in the record should be always on the bottom level. So this folders should help you really to structure your data, to sort it, to organize it, and if possible, the real files should be at the end of it. But of course, some things will be in between. And this is also important. Be consistent. So, of course, large but also small gaps can severely affect the entire system. So try to be as consistent as well. Revise regularly, maybe in a group. Try to get help from your colleagues. It is really something that can help. I said it is a toolless thing, but yeah, there is a tree size. It's open source. You can use this one. It's pretty handy when it comes to that. I want also to mention here, it depends if you work in a project or an institute. So you can use this rule for, of course, your project, but also for the institute work as an overall rule. Of course, the structure is different, but the rules are more or less the same. There are also some really cool short clips from the UK, from the Gent University, dealing with how to organize your data. And there's also a small workshop from the CAP, and this you can do on your own, how to working with files. So how you get your messy structure in an organized form that will save you a lot of time and pain. Yeah, we need, besides this data management plans and toolless work, you can also use electronic lab notebooks. So it was mentioned at the beginning, this is something I'm dealing with in my work. And electronic lab notebooks, as an example here, is eLab FEW. We are using this at Graz University of Technology. The idea behind it was just to replace a paper-based lab notebook, so that you can read what other people documented there in a way that is open to everyone, that you can also foster the collaboration between others, which is of course not possible with a paper-based book. And also that you have some kind of way to have a backup solution for that. So of course you could copy your paper-based work, but in this digitalized form, it's easier to use. This is just some screenshot how the work look like. It's the web interface, so it's a web-based application which is running on our institutional servers and are available for all of our researchers. As an example is here our Institute of Environmental Biotechnology. They had the need to digitalize some of their work in the lab, and their goal was to have a better organization of dealing with the high throughput of students and staff members they have in their institute. I think this is something that is common in universities. Also, this checking in and checking out part. They want the formalization workflow that they're using these eLab notebook also for that. But they also want a better organization of the data for all of the archive samples they have, but also for new ones. And also a better organization of samples on the product data. And this should not be a commercial for eLab, but it's just mentioned that you have no cost because it's open source and you can deploy it on yourself. But what is important here is the strategy that to try to introduce this new tool for their research community, for their institute, representing it to all tool members and started at different levels. So they started with students so that also the supervisors had to deal with the topic. And this was the idea was that it's slowly covering the whole institute and each and everyone has some connection point to this topic. So they have to think about how they could use this ELN in their daily work. Besides that, also data infrastructures for management and analysis can be pretty handy. And there are benefits to convert on your local machine, so on your personal computer. One of the benefits is that you do not have no installations. So if you work in a cloud infrastructure for data analysis and data management, you do not need a different kind of installations on your local machines. This can be also handy if your machine broke down. And you can access your data from everywhere. So it doesn't matter if you're at home, if you're at the institution, if you're abroad, it doesn't matter. You can access from everywhere. You can work from everywhere. And it depends on the solution, but usually you can work via the browser. So it's browser-based applications or via command line. And this is really important, you can easily include HPC resources, something that people struggle a lot. So you can do this and you can also share your resources like storage resources. So you can use them more efficiently with that. Also in regards of the sharing of open data and open software, when it comes to the reliability and the reuse of these things, you can use also container-based applications for that. So that you use them and reproduce your work easier. And of course, you're independent from your own system because one likes to use a Mac, the other like Windows system. So it depends. It's more easy for you. In this case, we have the Cybers Austria systems, which we use for organizing data. It also allows others to collaborate easily with sharing the information, with sharing files, sharing analysis scripts, sharing pipelines of analysis. And all of these things are using container technology. So the things you analyze, the things you produce is generated through the use of, in this case, our Docker containers. This is just a screenshot how this thing looked like in our university. At the end of the phase, or at the end of your work, it's common to publish, of course, your manuscript, your work. But what about the data? Where do you put the data? How is open data possible? Of course, it has to be published somewhere. And established journals also have their own data journalists that are purely concerned with the publication of the data itself. So in some cases already, through the review process of a manuscript, it's also required that you publish the data that is associated to your publication. So you have to have it in a structured, in an understandable way. And this data can also then be published in these data journals like scientific data, data in brief, MDPI data, data science journal. This is from a publisher side, but there are also other possibilities. So you can also publish your data in different kind of repositories. Sorry. There are 3 different categories. So we have discipline-specific repositories, like the Austria repository. It's the Austrian Social Science Data Archive. So we have an Austrian repository that is dealing purely with work with data from social sciences. There is also another repository called Pangea, I think that dealing mostly with geoscience stuff here. Then we have a cross-discipline, maybe all of you know Zenodo, which is a cross-discipline repository. So here you can publish data that is related to any kind of discipline. So you can do this, I think up to 50 gigabytes, 20 gigabytes, I'm not sure, is the limit where you can do this. And if available, there are also institutional repositories. In our case, it's the TU Graz repository, and this is a service that is hosted by our library. For you, you have to define your repository that fits best your needs. And there is a really cool site called reusability.org, which is a registry of research data repositories. So you can search through different disciplines and check out if there is a suitable repository for you as well. There is also another website. It's called fairsharing.org. I think it's that. You can also use this one to find a suitable repository, and also other things like metadata standards and so on. This is how our institutional repository looks like. So in the middle and on the right, you have just screenshots, how this looks like for the user. We always promote it for the researchers as a possibility to increase their citability. So by adding DOIs to their research, to the data, and also include this in the manuscripts. It's, as I mentioned before, based on a solution called InViewRDM. This is an open source software. It's also used by CERN. So Zenodo is also based on InViewRDM. And we are together in the core team with CERN in development of stuff. So it's something that will never be finished. So we are adding new features continuously to this one. So it's supported on the long run. Here we have also, you can see how this looks like from when you try to search something in the repository. So you see the recent uploads, so information that was uploaded recently to the repository. Then of course, if you want to search for different kind of things like a data publication, a software, presentation, whatever, also which license do they have? Very important here. You can also get an overview of that. And if you decide which one you have, you can also check it out, get some kind of description. In this case, the description is pretty short. You can see what files are attached to it. Can I work with those files? Do I have the appropriate software for it or not? How do I cite it? This can be done by copy paste. So this is all prepared for you. This is not it's not an up-to-date screenshot of the software. We have added some additional features in the last weeks. An example for that, again, from our university, is the Institute of Automotive Engineering. They had a little project like 1 year ago, which was also funded by our rectorate, called it the transfer of the existing experimental vaccines database for drowsy driver detection into an RDM database. And the idea was that the data that was gathered in a previous project from 2017 to 2019, with about 700 gigabytes of data, which were from 352 driving tests of 88 participants, that this data is organized, structured, and then in a way published that it is usable, or is usable for other research groups in our university, but also outside. So findable, accessible, and reusable, interoperable, of course, as well. And so they did this project. Also anonymization, of course, we had this extra factor with we have personal data here, so that is also the anonymization part. And which was also new or important in the project, they also tried to develop a business plan for the scientific and commercial use of the data. So they had some of this data open for everyone and some of the data for commercial use. So it's also possible with open data, not just to have scientific, to deal with scientific partners here, but also with commercial partners. So this is also something that can be achieved by fair and open data. And this is how I took that for them. They had 3 different data sets in here. One trial data, which was open for everyone, and then a small large data set with different amount of data, of course, but all with a really good description. And depending on your background, scientific or commercial, you had to pay for it or not. So this is one special case, how this thing then looked like for the end user. You see the description here is there's much more. Yeah, so which is also connected with the publication of data is licenses. And this is a really, really, really important point. So without licenses, you cannot publish your data appropriately. So I mentioned here some important licenses for data. The Creative Commons licenses are pretty handy. They are from CC0, which means no rights reserved, which means that when you publish it with this license, each and everyone can do whatever they want. They do not even have to attribute you. So I think this is maybe not the most usable license, but CC BY I think is the most used one. So this is really, you have to be attributed for your work and for your data. And there are also some others like the CC BY share, like non-derivatives and non-commercial ones. They are also important. And from my personal experience and personal view, if you want to be that your data is used by a broad audience, and of course you want to be attributed, but you want to be that the work that comes from your data or is based on your work is again available to others under the same license, I would recommend the CC BY share alike license. So CC BY and share alike. This is really a really good license that there are no limitations for your work and for your data, but you always get the attribution. This is also possible for databases. So for whole databases, they're also available. And of course, and I think you're all aware of that, also for software and code, there are all their own licenses. So MIT license, Apache license, the licenses with a copy left, some with no copy left. So there are different licenses as well in the EU. There's also this European public license which applies to EU law. I'm not sure if this is necessary to have this own European Union public license, but MIT, Apache, GNU, these are the most common ones for that. And on the right side, you have also a short visualization to see, okay, all rights reserved, so it's closed to no rights reserved. And in between, you have these different licenses here as an example for Creative Commons. Also as an example here for the use of different solutions in one working group is the Institute of Solid State Physics. They also had a project that was supported by our rectorate, and it's called Research Data Management for the Graz Micro-CT Consortia, so for micro as a computed tomography. And here we had 3 universities included, so institutes from the Graz University of Technology, from the University of Graz, and from the Medical University of Graz, so all of the 3 big ones. And they got 2 new instruments here. And the idea was to use this as efficient as possible within this consortia. And so they came up with a plan how to do this, always in the background of good RDM practices and the tools that are available out there or in our university. And so they had with this computer tomography, a lot of data created in a really short time. And they had different, or they have different customers from different universities with their own samples, and of course with different analysis time. So a lot of data in short time with a lot of much metadata information as well. And so they created a system where the information is first saved on local storages that are directly connected to the machines as well, and then moved on to a NAS system where the data is, in this case, the raw data, but also the reconstruction data. So the process data is saved on the long term on magnetic tapes. But in the meantime, the data itself can be, this is depending on this in the application, can be processed on local drive, but also in the Cyrus Austria platform. It can be saved later for publication in this Invenio RDM system. So in this case, it's our TU Graz repository system. So to make it available for others, they used the open data to publish it in the TU Graz repository. And for the documentation of the metadata and for the experiments or for the runs itself, they used electronic lab notebooks. In this case, it can be the LabFW solution to do the documentation as well, which comes pretty handy when you have to also talk about the runtimes, how much the partners have to pay for it. So you need a proper documentation. This can be done with a combination of all of those tools. But that's not all. They also developed their own folder structure. So something I mentioned before, toolless solutions, and also their own file system. So for all of the experiments they're doing, for all of the runs they have, they created a system that really sees, okay, which run to have, where are the acquisitions, the reconstruction, where's the experimental databases, where are the IDs for the prices, so that you can do the pricing correct, also the analysis. And they have a unique naming system for each and every experiment, so that it's clear for every user with the codebook, okay, which file I want to enter to get the right experiment. So this is maybe the last part, the role of a data steward in all of this ecosystem. And to explain this, I think it's important to see the difference between data stewardship and data management. So data stewardship is, so data stewardship refers to the responsibility of overseeing the management, the quality, and the use within the organization or a research project. So the idea behind data stewardship is that institutions as a whole need to establish practices that support the researchers in their work. Also, maybe some tasks or skills they have to learn in making their data fair and at the end, of course, open. And data stewardship is some kind of process to this. So a process of transformation that to the data lifecycle to make data fair and open, and also some kind of cultural transformation. And at the end, it also something like a skill set that some basic skills in data stewardship that each and every researcher should have. Data management on the other side deals with the operational parts. So really that affect the whole data lifecycle in this thing. And the idea behind it that we want to maximize the value we have of the data that is already available or will be available in the future. And on the one side, and also to minimize the risks of losing it, like appropriate backup solutions, and also ensure that we are working in compliance with all of the political or whatever regulations and policies there are out there. So this is the operational part. You can also have an illustration about that. Maybe it's easier to see like that. You can see we have three parts here again. We have on the one side the researcher, the research itself. So the specialists who work in the field, they use data workflows, appropriate tools, standards, and infrastructures. Then we have the infrastructures providers itself, like our central IT services. that they're trying to align with the researchers' needs on the one side, but also have a infrastructure available that is cost efficient, but also useful for our needs and the policymakers. So people who are develop the guidelines, who are creating the policies, also have to deal with things like GDPR. And data stewardship on its own is a link between all of these areas. So there has to be some kind of connecting factor. This is called data stewardship. And the people who are working in this field of tension are the data stewards itself. In Austria, we had also a project called Fair Data Austria, where we tried to implement data stewards. And so this concept of data stewardship in Austrian universities, we also had a short booklet where we tried to describe the outcome of the project with the models we identified for data stewards, with the profiles of data stewards, the competences and training. Here you can see also the models we saw, which are appropriate in Austrian context, like a data steward contact point, which is just one steward working for the whole university as a contact point. So he has some basic knowledge and can forward information to the right people. You have an office like with several stewards that have proper education in certain areas of research and can also directly support the researchers, and also a network where the data stewards are working directly in the institutes or in the faculties together with the researchers. In principle, what is a data steward now? So what is important for him? So data stewards are RDM experts. So they know everything that is important about RDM and have an advisory role throughout this whole research data lifecycle I showed you a couple of times in different forms in this presentation. And when you think back about this data stewardship image, there are communication interfaces between the researchers, between the policymakers, between decision makers, between software developers, infrastructure providers. So they try to work in this field of tension and to communicate the needs to the others. And this is also really important, they are promoters and ambassadors for the FAIR principles. And of course, in some way also for open data and open science, and help or facilitate the transition to these modern RDM practices for the researchers itself, but also for the institutions. So it's not just the researcher, but also the institution have to think in new ways of doing the work. And
Alexander, you have 2 minutes.
2 minutes, okay.
Yes, so we will have some time for question.
Okay,
as well.
yeah, it's just 2 slides, so okay, yeah.
Yeah.
Okay, there we have some different competencies. You can check them out later if you want, that people should have. In Graz University College, we have right now 3 data stewards from life sciences, physics, and medical engineering. There are some benefits that come with those. So we have DMP support, data science support, RDM tool support. We try to network people, try to network researchers in our university. And also we help a lot with implementation of different things. You can see this here as well. We do also one thing that's called RDM optimization analysis, which is something where we try to work directly with research group in improving their RDM situations at the institutes and try to build up sometimes infrastructure, but also tools and regulations, how they do their daily work. So the conclusion, last slide, practices towards open data. So important points for RDM and open sciences policies promote a culture of openness, collaboration, and integrity in research. So really important to have this framework, but also advance the scientific process and benefiting society as a whole. So this is important, a really important aspect for the policies. Then institutional RDM support is important because it acts through specialized tools and services, which are important to make your data open and is in the best case driven by the needs of our researchers and promotes the fair data. Then data stewardship is a change and a challenge at the same time in the scientific culture. It's not just a technical issue. Experts in change management are really valuable if you have someone available, but it's always important in this case that you understand and discuss the criticisms and fear that is also available here. They're also present here. So always work solution oriented and empower researchers and do not create additional burdens. So all of this RDM topic, data stewardship topic should empower researchers and do not create additional work for them. And data steward itself, have a supporting character and they do advise people, but they do not dictate or judge. That's not the role. Because researchers are the experts of the data. That is something you have to keep in mind. But data stewards open up a modern perspective and help to overcome these new challenges that come with these modern RDM solutions. Yeah, and the last slide, I just wanted to show this again because these goals and benefits are really important. Maybe you have time later to see this again. Okay, thank you for your time. I hope this information was presentation was interesting for you. And if there are any questions, I'm happy to answer them.
Thank you very much, Alexander. There are two questions in the chat. How effective management open research data can support improvement, social well-being and development, new technologies in fields of agriculture and ensuring food security? Okay.
This is, I think, not easy to answer this question because I'm not from a university who is dealing explicitly with those topics, but of course there are ways how this can benefit from it because you can produce information that is connected with the how the conditions of the soil of the where you produce the food is or something like that, and this information can also be meteorological data. Is sometimes not open because it's behind a barrier. They have to pay for it, and to make those informations available also for people in countries that cannot afford, like several areas in Africa or South America, to open this data, to use them for their own analysis concept can be really a powerful tool to improve their situation there. This also, of course, as I mentioned before, can be done with make your analysis or your simulations available for them in a way that they can use it with their own parameters if they differ from your own geographical situation. So this can be one factor, but of course, someone who is an expert in this field is much more talk about much more positive aspects.
Thank you. Another question from Professor Daphna Rabban from Haifa University is there a role for the university library in your data management implementation?
Definitely. So I did not mention this before, but our research data management team is part of our library at Graz University of Technology. And to keep it simple, to have these repositories in place, it's kind of a treasure chest, and the treasure chest of the information, the data that's available. And we think, and I especially think, that this is something that should be directly connected with the library or the library services in a university, because this is the place where the information should be gathered should be available. And so we also try to connect things here with other services that were already present before our team started the work. So in our university, in our repository, not just the data is available, but also information from manuscripts, from work from bachelor and master students, and also open educational resources. So we try to combine all of this information that was available in the library together with the new stuff that was created.
Thank you so much, Alexander, for taking the time and sharing your experience and all the amazing work that you do in Graz University.
It was a pleasure.
Thank you for a very interesting presentation. And I think that's it.
Yeah, thank you. Thank you for your time.
Thank you.
Bye.
Bye.
Bye-bye.
Thank you very much.